Ignition sequence start.
Good morning. You're looking at Mission Control Houston, where the International Space Station Flight Control Team is working with the Expedition 63 crew members as they get set to greet the arrival of 2 new crew members due to arrive soon on a new spaceship. Commander Chris Cassidy and his Russian crewmates are standing by with the rest of us to see 2 of their NASA colleagues ride a SpaceX Crew Dragon vehicle to orbit from a Florida launch pad and open a new era in space exploration.
Welcome to Space to Ground. I'm Sarah Volkman. All of NASA and SpaceX are gearing up for what is going to be another historic day in human spaceflight. On Saturday, May 30th, NASA and SpaceX will launch humans to the International Space Station inside an American vehicle from the Florida coast. After several years of collaborative development, training, and other preparations, the Demo 2 mission will kick off with a launch from the Kennedy Space Center's Launch Complex 39A, carrying NASA astronauts Doug Hurley and Bob Behnken. Liftoff is scheduled for 3:22 p.m. Eastern. The Crew Dragon will travel to the International Space Station, checking off many operations along the way before beginning its rendezvous and docking procedures. It is scheduled to dock to the International Space Station Sunday morning. The continuous coverage of the DM2 mission will last from launch until the Dragon hatches open and the crew takes part in a well-deserved welcome ceremony. They'll be joined by friend and station commander Chris Cassidy, along with cosmonauts Anatoly Ivanishin and Ivan Wagner. As always, you can watch it live on NASA TV, nasa.gov, and on all of our social media. In addition to preparing for the Demo 2 crew's arrival, the current space station crew was also busy capturing a special delivery. The HTV-9, a Japan Aerospace Exploration Agency cargo craft, was captured by the crew using the space station's Canadarm2 robotic arm Monday morning. It was installed to the space station's Harmony module shortly after by robotic arm operators in Mission Control Houston. It will remain on the space station for about 2 months before being released, marking the final mission for this class of spacecraft, called Kounotori. Keep sending your questions using the hashtag AskNASA, and share your thoughts on the historic launch of the Crew Dragon from Florida using the hashtag LaunchAmerica. We'll see you next week.
The new Expedition 63 crew members will include one of the astronauts who was on the last Space Shuttle mission, which flew to the International Space Station almost 9 years ago. NASA astronaut Doug Hurley is commanding the first SpaceX Crew Dragon flight with astronauts on board. Listen to him talk about the plans for this flight, his career as an astronaut and the keys to a successful spaceflight, and the immense team needed to make this flight a success.
Hi, my name is Doug Hurley, and I'm the spacecraft commander for the Demo 2 mission to the International Space Station. This mission is the crewed test flight for the SpaceX Crew Dragon. So every portion of the flight, this will be the first time the Crew Dragon has had a crew on board. And so there's a myriad of objectives we want to achieve. Obviously, the first part is to launch the rendezvous and docking phase. And then we'll spend some time on board space station and do some dock activities with the vehicle. And then at some point, 30 to 90 days later, we will undock and do an entry and a landing in the Atlantic off the coast of Florida. It's a story. On STS-127, which was my first flight, I think we scrubbed on the order of 6 times over the course of about a month. It was literally Groundhog Day trying to get into space. And of course, it's your first flight, so you really, really want to go. We just had technical challenges for the first 2 or 3 launch attempts, and then had to scrub for weather a number of times before we finally got to go. That's why you got to go to the pad, you got to get in the vehicle, because you never know when the weather's going to clear. It's not the best of stories, but I think back so fondly on that mission. We worked really hard for 16 days, but it was a great mission once we got airborne. We first got down to Kennedy, we got every checklist out and every responsibility that each one of us had, we kind of almost tabletopped it for the first couple days. And you see that in sports teams. You see the coaches and players that spend that extra time after practice and at night reviewing film and going over films of the other teams. I think that's what you need to do in a space flight, is you need to know what you're going to do almost instinctively, if not completely by heart, and then go from there. And I think it sets you up for success. With the shuttle, you were on your back for almost 4 hours waiting to launch. So part of it was just, let's get this over with and get going. But then when the engine's light, you know you are going, and you know you're going somewhere pretty fast. And you go from, in the case of the shuttle, you go from 3 Gs to 0 Gs instantaneously, and things start floating. And I remember distinctly just thinking, what just happened? Because 8.5 minutes ago I was on Earth and now I'm in space. And obviously with Falcon 9 and Dragon, this will be the first time humans have ridden on the Falcon 9, even though it's flown many, many times. You tend to pull more Gs. The first stage is pretty similar. Like shuttle, we had about a 2.5 minute first stage. The difference is going to be with Falcon 9, the engines, you know, you separate from that part of the rocket with the engines the first stage, and so you get kind of a weightlessness there for, or a lack of acceleration there for a split second or two. So that part of it is going to be distinctly different. We could experience somewhere on the order of 4+ Gs, whereas shuttle, we were limited to just 3 Gs. I think our concentration has mostly been on, you know, the profile, the crew vehicle interface, you know, just how the Dragon will work for crews going forward. That's why we're going to do this flight now, is to prove out what we think it will do. Ideally, it will do exactly what we expect it to do. The first simulator where we integrated the Hawthorne mission control team and the Houston mission control team was a huge moment, to be able to just have the entire integrated team that's going to support us getting to and from space station, talking together, working through the challenges. I think that was probably for me the first big highlight, and that wasn't that long ago. It overwhelms you to think about how many people have in some way, shape, or form touched this program and this vehicle to get us to this point. You know, we obviously in a lot of ways are the lucky ones that get to fly it, but we certainly not for 1 second take for granted the amount of effort that so many other people had to put into this to make it successful. And you know, we'll do our part to make it successful and to get back here and celebrate with everybody in a few short months. Very excited. Yeah, very excited.
We'll meet the other new station crew member in just a few minutes. For more than 19.5 years now, there have been astronauts and cosmonauts working on board the International Space Station to advance its mission of preparing for future space exploration, providing benefits to people on Earth, fostering international cooperation, and commercializing spaceflight and space research, and expanding scientific frontiers. The men and women who will come to the station on the new commercial space vehicles will contribute to that legacy. All of the experiments that International Space Station crew members work on are the brainchildren of scientists on the ground, men and women who came up with a hypothesis to test and then designed and developed an experiment. In this episode of the new season of the NASA Explorers series, we watch as the scientists work through the last stages of getting their experiment loaded on a SpaceX cargo ship for the trip to orbit.
You know, we're excited to see what kind of data that we collect from this first project. Any sort of data we get is going to be brand new information for us and for...
Three, 2, 1, and 0. And a liftoff of the Falcon 9 rocket and the Dragon spacecraft, packed with science and supplies for the International Space Station, humanity's home in low Earth orbit.
So we were originally scheduled to be on SpaceX 14, but about a week before launch, our project got canceled from that launch because of some issues with the controlled environment.
Science in space can be complex, and no matter how meticulously things are planned and executed, sometimes those complexities get in the way of launching on time. When equipment used to house the experiment didn't look perfect for a final pre-flight test, there was no choice but to push it to a later flight to ensure mission success.
As a first-time investigator, that was, it wasn't devastating. It was just sad that we weren't going to be able to launch because up to that point, it had taken us about 2 years to get there. Ultimately, it gave us about 6 months more time to reevaluate that controlled system and do some more groundwork to prepare for the launch in December of 2018 on SpaceX 16.
After the setback of being moved to a later launch, our team of scientists now has only days left before their experiment will be loaded into a SpaceX Dragon capsule that will carry it to the International Space Station. Elaine and Parastu, the co-founders of a biomedical startup, are at NASA's Kennedy Space Center, readying their research for microgravity.
Since this is our first project that's launching to station, this is also our first time working at the Kennedy Space Center. So it's been an exciting moment to, not just see the visitor center and go look at the touristy things, but also get past the security gate and into the actual laboratories.
While some experiments are loaded into Dragon in the weeks leading up to launch, others have more time-sensitive components. These require precise preparation and loading in the days before liftoff. For those scientists, laboratories at the Kennedy Space Center that are a part of the Space Station Processing Facility, or SSPF, become a home away from home. Here, they can carry out the critical last steps of preparing their experiments for delivery to the space station.
So we got here on a Thursday, and it's currently Sunday. Been a big day yesterday filling up these wells with gel solution and getting ready for handover at 7:30 a.m. on Monday, ahead of launch on Tuesday afternoon.
Once you arrive here, you kind of get into this other time. It's this weird little time bubble where everything is now L-based, and L being launch, and it's L minus 72, L minus 48, L minus 24, and it's just building up to the actual launch time.
With those precious remaining hours, the team is prepping their microplates for microgravity. Microplates are also used in labs on Earth, but these were specially designed to be self-contained.
My role on the project was to design the actual microplate themselves. The challenge on orbit, though, is that generally fluid experiments have to be conducted in the glove box, and the glove box is very time limited. It's very crew intensive. So we've designed this self-contained microplate that can be operated outside of the glove box. It has all of the containment to keep the fluids inside.
So we have loaded these wells with hydrogels that they were carrying drugs, and we want to actually look at the effect of microgravity and how the release of the drug is affected when we send it to the space station. So the concern that we have is that if we have bubbles that are in the wells, it may be difficult for the plate reader to be able to read the amount correctly. So we are being very careful with how we are loading the waters.
So what's left to do today, once Parastu here finishes filling the microplates, I'm going to take over and seal them up completely. Once that's done, we'll add all of the labels onto the microplates and put them in a self-contained box that is what they'll actually travel to the space station on.
3 years in the making just to get here.
Once we do that, we'll turn it over to Cold Stow. Cold Stow will take it from there, and the next time we'll see them, we'll be on orbit, and the crew's opening them up.
Cold Stow, short for cold stowage, is the team responsible for making sure that the research stays at the right temperature on its journey from the lab on Earth to the lab in space. This handoff is one of the last steps before being loaded onto the rocket. The cold stowage team will take Elaine and Parastu's experiment and keep it safe and sound before it's loaded for launch.
Does it feel like a relief?
Well, it'll feel like a relief when we actually see it take off. And then it'll be finally...
It's a huge step though.
Yeah.
It's done. It's out of our hands at this point.
Yeah. It'll be officially out of our hands when it leaves the Earth's surface. So that'll be the moment that we're finally done. Until we get data, and then we get to process it.
That's just the beginning, actually.
So what'll happen now is, now that we've handed them over to NASA, NASA will deliver, they're on their way right now out to Dragon to be loaded. And the launch hopefully will happen tomorrow at 1338. I've been involved since the very beginning, which is approximately about 3 years ago. It's been a long road, but like everything, it's a lot of work. It's worth it. And we're excited to help Tim Panagen get some data for this project.
Overall, we're going to get a lot of data from just this one project and those 2 experiments that are going to inform a lot of different things for us. All right.
It's a little windy out here today. It's a beautiful day. It's a little windy. It's got me concerned. My launch intuition is tingling a bit. It's always an awesome and amazing and special thing to see.
The new astronauts, who are days away from joining the International Space Station crew, are both veterans of previous station visits. In this feature, NASA astronaut Bob Behnken talks about his career as an astronaut and how his Air Force background prepared him for this first-of-a-kind experience.
Hi, I'm Bob Behnken. I am the Joint Operations Mission Commander for NASA's SpaceX Demo 2 mission. So Doug Hurley and I are about to take NASA's SpaceX Demo 2 mission to the International Space Station. During that mission, we'll perform some checkouts, everything from a response to a fire on board to flying close to the International Space Station manually. We'll make sure all those systems are working during the test flight so that the future missions will have them available even if they don't plan to utilize them. We're hopeful that future crews on Dragon vehicles headed to NASA space station aren't cursing our names because we accepted some feature that was complicated and hard to train and in the end hard to operate. In the Air Force environment, flight test environment, there's always a balance of managing risk as you go forward to execute a test point and figuring out a way to collect the data. And do that in the calm, cool, collected kind of test environment with experienced folks before a pilot ends up someplace a little bit more complicated with a lot less resources. My role for a space mission is very much the same. My career at NASA has kind of spanned a couple of decades at this point. I arrived with the class of 2000, went through the training program, primarily focused on the space shuttle and the International Space Station, learning those systems through the assembly process, which was a little bit like where we were with Dragon in the early days, because Space Station kept changing and you had to stay up with it. After that, I was eventually assigned to a series of kind of training activities, both as a long-duration crew member and then flip-flopped over and flew a couple of shuttle missions, both on Endeavour. After that, I came back and kind of worked up the leadership chain through station operations, deputy chief, and then chief of the astronaut office. One of my goals was to try to get as many astronauts off to Kazakhstan so they would appreciate the day when we got to launch again from the Florida coast. probably two things that jump out to me as kind of big wins. One is associated with having a high enough fidelity from a training perspective. Both Doug and I can sit in a capsule, we can put on suits, and we can go through a situation or a scenario where the suits are going to inflate to try to protect us from whatever situation is developing on board the vehicle. I think one of our biggest accomplishments was a tool to be able to plan our own way out of orbit back to Earth, and we had to come up with a way that didn't break the software allocation that was out there, and we just had the big picture of, okay, how does the crew just get home if they end up in this situation? How does the crew get home if they end up in this situation? When they were able to flip that switch and not count how many failures it took to get there, but accept that let's figure out the easiest way to provide that capability, and they got on board with it. That was the aha moment. You don't necessarily have to save the mission with the crew, but you need to save the crew with the crew is kind of the mindset that we've put out there. It's really kind of designed that launch day is kind of relaxed. So we'll get up, have a little bit of exercise probably, or breakfast and then some exercise, be able to do some last minute phone calls. We'll probably have lunch, review, weather briefing of some sort to understand what our weather's going to look like. We'll hear anything associated with the vehicle, kind of technical detail wise. We'll get a little bit of an early read on that before the formal process of getting the suit on and then heading out to the launch pad. For me, having launched a couple times on vehicles, the second time was definitely different than the first time in terms of relaxation associated with the mission. You're doing that for the first time, you can feel a little bit guilty of, hey, should I study one more thing, or is there one more piece of information I should get? So that's definitely different between where I was on my first flight and where I'm at right now. On a deeply personal level, I'm really excited that my son is going to get a chance to see me launch into space. Being an astronaut has been a little bit of an abstraction thing for him because he's seen me do it in old videos, but he hasn't seen me do it for real. I think it's important for the U.S. to continue to have these exciting things out there from a technical, engineering, science, challenge perspective, because it motivated me to go into this sort of a career, and I know that it motivates other children in. And so I'm excited to bring it back to the Florida coast, or be a part of bringing it back. I'm just one piece of a multi-thousand member team that's going to hopefully pull this off in short order. It's inspiring to me, and I'm just excited to be a part of it.
Bob Behnken is just one among the many astronauts who reported feelings of awe and wonder when they got their first look at the entire planet Earth from orbit. Here, former astronaut Mike Fossum talks about what it was like to really devote some time to Earth observation from that perch 250 miles up.
I've taught astronomy to Boy Scouts for most of my adult life, and know the summer stars in particular like the back of my hand. And I've sought out, I've lived in the Mojave Desert for 8 years, and I would go away from the lights there, even as meager as they might be, to lay on top of a car and just swim, in the universe. So I've always loved the night sky and the stars. And so on my very first shuttle flight, both of my shuttle flights, we took some time. I convinced my crew to turn off all the light in the cockpit, let our eyes dark adapt, and just sit there perched in the windows. All of us were in different windows, and you could see, the Milky Way is just stunning. Of course, the lights don't flicker, they're steady, because they're not coming through the dust and coming through the atmosphere. As you really adjust, you start to sense the very subtle colors that are in the stars. A little bit of reddish, a little bit of bluish, blue-white. And that was, really neat for me to see. The space shuttle was incredibly busy, though, and you don't get much time to look out the windows. It was having the downtime. So you work really hard. The Monday through Friday was a blur. Working late, you're living at work. There's always more to do. And then weekends, it slows down some. There's some work. work out, have a video conference with the family. But you do have some time for some projects and for looking out the windows. And I really got into low light photography in particular. The cupola was fairly new. We had some fairly new cameras, the D3 that was good at capturing low light imagery. I was up there during the last space shuttle mission. So STS-135, Atlantis was docked to the space station. And I grabbed Sandy Magnus, a good friend of mine, and she was on that crew. And she had lived on the space station a few years before, but the cupola was new since she was there. All they had was single windows that looked straight down, and there you're just watching the Earth go by at 5 miles a second. You haven't looked out the cupola yet. Come on, come with me. I've got so much to do. No, Sandy, you have got to see this. So we went in there, cranked the shutters open, and we were flying into this astonishing aurora. Aurora Australis, the Southern Lights. This rippling, pulsing river of green that's down below us, the red that is stretching up to our altitude. It's like, it was just breathtaking. And I had not practiced any low-light photography up to that point, but I knew right then that I had to figure out how to capture this, and so I started working on that. I called the photography experts on the ground and said, okay, what are the settings I used to get started with this? And part of it was experimental. I had to get close and then start trying. I got some pictures actually of Atlantis docked to the space station in the night with a little bit of the green aurora off to the side. And then I got a picture of Atlantis's plasma trail as it came in over the Yucatan headed toward its landing in Florida. And it's just fascinating. The more you look, the more you start to see the stars like you have never seen them before. I'd give a lot to see that view again.
If you'd like to get another look at any of the stories we featured today, check us out on YouTube and Facebook. There are the addresses. Be sure to look around. There's lots of other cool stuff that you'll find about NASA and America's human spaceflight program. If you're going to be out on the internet anyway, you could also check out Houston We Have a Podcast. It's where we talk to folks about their work in all aspects of space exploration. For example, in today's new post, Gary Jordan talks with two of the divers from the Neutral Buoyancy Laboratory about their work helping to train our astronauts for the spacewalks they do on the International Space Station. Go to nasa.gov/podcasts for this week's episode. It's where you'll also find all of our previous episodes and the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud.